Okay, welcome everyone. Hello, this is Ryan Muir. I'm a product marketing manager with Smarty, and I've got Easton Gibson with me. He's a software engineer with Smarty as well. Welcome to this 10 o'clock session of Pinpoint, where we're going to talk a little bit about, creative and creepy developer hacks that you can use with addressing data. I'm happy to turn the time over to him. Go ahead and take it away.
Thank you. Yeah, I'm super excited to be here and to share the creative and creepy hacks I thought up while preparing for this presentation. Here's a little layout, a little plan for us, what we're going to be covering today. Um, Start with a warm up, and then we'll basically just go over the Smarty products I'm going to be using in order to accomplish what I'm going to accomplish. And what I'm going to accomplish, I have described as elements, meteorites, and neighbors. I'll just let you use your imagination on what those mean until we get there. Just be a little fun. So we're going to start with a little fun warm up here. Just a little fun fact, I guess. Um, we call this shared delivery point. The way this thing works here is there's certain addresses out there. This is by USPS definition that uh, they're a little wonky. Their secondary designator, uh, in this case, we've typed in unit. They'll actually just accept any secondary designator and still say it's valid. So I can switch this from unit to apartment, and it'll still be like, oh yeah, like this is the right designator for you. You might not be aware in a normal address, if you type apartment and it's actually unit, it'll change it and say, no, 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 it's unit. But these shared delivery point addresses are kind of like little glitches inside of the USPS's system. And I think a more entertaining secondary designator you can throw in here is something like hangar. It'll accept hangar. It'll accept penthouse. So yeah, those are kind of fun. Just wanted to throw those out there. Let you know those are in the world because there's things like that you discover every day working on the products at Smarty here. But anyways, back to more hacky-like things. So I want to start off by laying the groundwork for the APIs we're going to be using in order to accomplish some kind of crazy stuff. So we have US Street API. This is our main validation verification API for addresses in the United States. Um, the information you send to it can be as simple as just the street field, and this is the address for the Smarty building here. And then it'll return a whole lot of stuff. The main thing you'd probably think it's going to return are components. Tells you the primary, street, state abbreviation, all that jazz. The Smarty key, that's going to come in real handy for us later. And the delivery point barcode is a delivery point that the USPS has assigned to it. We also have some analysis data that tells you how valid the address is. If it's vacant, which it's not, Smarty Building's not vacant, it's good to know. There's some metadata like some geocodes. You got the precision level. This is rooftop precision. You got the time zone. You got the county FIPS. Lots of useful information. But the thing we're mostly interested in today will be the Smarty key. The Smarty key of our building here. Smarty keys have lots of uses. You can look up addresses in your database by Smarty key. You can dedupe your data real easy, and you can link to enrichment data sets, which is going to be very important in our later in this presentation. Yeah. Then there's Reverse Geo. We'll also be using the US Reverse Geo API. Essentially, you give it a longitude latitude point, and it'll return you the 10 closest addresses to that point. You can specify the source to be postal data or all data that we have. I believe in this example, I think in every example I'm doing today, we're just doing postal data just because it's got more interesting stuff on it. And then, as you can see, we also return a Smarty key with those addresses and the distance from the longitude latitude point that you sent in meters. So we'll go over that again when it comes up, but that's going to be the important part. And then the enrichment API. The enrichment API takes in a Smarty key and can return you so much data. We have lots of different data sets. The example I have here screenshotted is from the property data, but we will also be using the risk data today. So there's a bunch of, I mean, there's hundreds of points of data that you can get from the enrichment API, but the important part is it takes in Smarty key. All right, elements. Everybody is born with a desire to control one of the four basic elements, I think. And there's plenty of online quizzes which you can, take those that will tell you which one you fit best with. But maybe you're more practical like me, and you think, well, I want to know what one is best for where I live, and that's why I've created this API here, or well, I call it an API. It's really just it's stringing together of several Smarty APIs. So what we're going to do here is we're going to type in an address. We're going to look it up, get its Smarty key from the US Street API. Then we're going to use that Smarty key in the risk data set. And then we'll use a special algorithm I've derived that will tell us which element it would be most important for you to control in this location. So without further ado, let's get into some code here. So this is Go. I wrote this all in Go, but our SDKs look very similar in all languages that I've used. So this get Riv credentials, you're going to see that. Riv is short for Rivendell. You might know it from Lord of the Rings, but it's also the name of our test environment here. So that's why it says get Rivendell credentials. So that's just a little function for me to get the credentials for my US Street API instance. Just abstracted that away for us. But basically, I'm using the I actually don't know I think it's called secret, or it's get credential. It's wire up dot credentials. I think it's secret key credential. That's what it is, and it takes in an auth token and an auth ID. And then I gave it a custom URL because I'm not hitting our live APIs. I'm just hitting our dev APIs. The lookup here for US Street takes in the street as you saw on that payload, and then I'm specifying the match strategy of enhanced because if I don't specify enhanced, I won't get a Smarty key. But that's the entire payload right there. Just take the street, which we'll see when we enter it, and then you have send lookups with your client that you've set up. And if it returns any errors, we will print those errors out and we will return the lookup. We also have our risk data set lookup, very similar. I'm just going to set up the same credentials and then give it a Smarty key in the lookup, and then fire off our send risk because this client is a US enrichment client, which means it has access to every single data set. So we have to specify that we want the risk one. So send risk, that's what that function does. And then we return our response, which is just a bunch of risk responses, which we'll dig into. So our best element choice will get Smarty key from input. That's a good point, actually. I originally did do this by address, but then I decided for the sake of demoing it, I probably wanted to just do Smarty keys so we could hide a little privacy of the addresses we're sending in. Because I honestly have no idea who lives at the addresses that I've chosen. So the risk data set, you do the lookup, and then you do this fancy algorithm down here after you make sure that we actually have a response to use. And then in our fancy algorithm here, we simply took all of the different risks associated with your address and decided summed them all up. So you can see I took all the ones I decided were water, like avalanche, hail, heat wave, tsunami. I thought, well, you'd probably want to control water if you're going to be in a risky area like that. Or we have like the hurricane for air. I think hurricane's also included in water too. Yeah, there's hurricane over there.
Yeah.
We have cold wave if you want fire. We have landslide for earth. We have volcano or volcano for both earth and fire. But if you want to see the full documentation here, here's our risk values, and you can see that there's lots of them. I chose to use only ones that were EALB, which is just the expected annual loss building value. But it's kind of arbitrary. I just picked one that it seemed to make the most sense to me. But yeah, this is our documentation you can look at to see if there's other things you'd be interested in. Like somehow you could work drought into it. I was unable to. There was no EALB value for drought, so I didn't work drought into this algorithm. Plus, I didn't think it'd be helpful to control any of those elements, like unless you could spontaneously produce water. But that wasn't exactly what I was going for. So now we have our demo, where I will try and demonstrate how this works. So let's see. We've got the best element choice. It wants a Smarty key, so we'll take our first Smarty key here and send it on in. And it says that fire is the best for this location. So this is probably the one that I did in Nevada. I went to an area that was very prone to wildfire, and yeah, you can see that the values are different for all of them. This one's a water location. What I found by hitting lots of addresses throughout the United States is that water is the best choice for most places. So if you don't have access to this tool, just know the answer is water. Um, this one is probably our air guy. Oh, this is our earth guy. All these values, I believe, are dollar amounts. I'm not exactly sure how you're supposed to translate it risk wise. What do you have we have a question?
Oh, just that was one of the questions was what are the values that are coming out?
Yeah, so I believe the values are dollar amounts. I don't know how you're supposed to interpret them
Yeah.
because do you know, Brian?
But it seems like it might be really helpful for like insurance adjusters and
Yes.
policy creation for things like that. Um, but that's really cool that you're able to string those together. I'd love to see more.
Yes. Oh, there will be more. Don't you worry. But just to prove that it's useful to bend or to control all elements, let's oh, there we go, air. I believe this one's in New York somewhere. And it barely got beat out or barely beat out water. So like I said, water always a good second choice. So yeah, that's our first hack, I guess. But don't wait or don't worry, it's gonna get way more complicated. So we have meteorites. This is, have you ever wondered what it would be like if a small meteorite leveled your house to the ground and also several houses nearby? Would you like to know how much money that's going to cost? Then this is the project for you. So what we're going to do is we're going to enter an address and a radius. In this time it'll actually be an address, by the way. I won't abstract it away to a SmartyKey. We'll enter an address and we'll enter a radius. And then we will use the US Street API to get the geocode. We'll use reverse geo to get the 10 closest addresses. And then they also give us distance. So we'll use that to track if it's within the radius. And then we will filter out only the results that make it within the radius. And then we will look up the assessed value from the property data, and we will add all those numbers together, and we will see how much damage our meteorite did. Um, so this is the same street lookup, so I'll just breeze over this real quickly. Here it is. Reverse geo, this one's new. Same thing, get our credentials, but then we'll provide a longitude, latitude, and our source of postal. And then we will send the lookup. So if you might start to notice a pattern with our SDKs a lot. They are all very similar. I did not have to look at the documentation for them past a certain point. I looked up a few of them and then was like, well, I think I got it. So that's nice for chaining the APIs together like this.
That's something they can expect from Smarty pretty regularly, right? It's simple
Yes.
SDKs that are
Yeah, and the terminology will stay the same across all the SDKs, not just the Go SDK. The pattern is propagated through all SDKs. And this is the same lookup for enrichment, except for now it's doing a send property principal instead of a send risk. So once again, just takes in the Smarty key, sends it off. All right. So we have a problem with this one though. It's that what if the radius that we set for our meteorite is going to hit more than 10 houses? Well, that's where our first real hack comes in. It's hacking Reverse Geo API. So what we're going to do is we're going to take the results we get from Reverse Geo and send them back through Reverse Geo. So it'll give us the 10 closest. We will take those 10 closest and we will then send them back through and get their 10 closest and get their 10 closest and so on and so forth until we get every address that is within our radius. So to do that, we have some code here. I am building a result map. That way I don't get any duplicates. We will be keying it off of SmartyKey. So that way, if we've seen that SmartyKey before, we know, well, we've already seen that result, so no need to store it again. And then right off the bat, I'm storing the SmartyKey for the first address that we looked up because I already have that SmartyKey. I already know we're going to hit it. Unless your radius was a negative number, it's going to be 0 to that distance, or the distance to that point will be 0. So I'm just automatically including that one. And then we have a little helper function here for some recursion. Basically, we're just going to do the reverse geo lookup we're going to loop through the results, and if we already have it, then we will skip it, and then we'll check the distance. And if the distance is less than the distance, great naming convention there for me. If the dist is less than the distance, basically
Yes.
if the current distance is less than the distance we're looking for, then uh, we'll put the result into the map, and then we will call the radius helper again. We will just keep doing this looping over and over again until we've hit every single house within our radius. So there's a minor pitfall to this that I have sketched out for us. If you do it in houses that are, let's say I, typed in 300 and I targeted this house. Well, this house here, its 10 closest houses are going to be these ones. And also this house right here, its 10 closest houses will also be these ones. So it's possible it gets stuck and it's never able to jump over, say, this empty field because all of the houses uh, are closer to this one than they are to that one. They'll never be able to jump into that neighborhood. So that's a minor pitfall with this algorithm. Also, another minor pitfall, maybe more major pitfall, really, is that this algorithm ends up using a lot of lookups. On average, it's about 1 to 1. So for every house that you get in this, you do one reverse geo lookup. So even though reverse geo finds 10, by the time this algorithm runs its course, you average about one reverse geo lookup for every Smarty key that you're able to harvest with it. So be aware of that before implementing this. Um, well, we're on to our demo. So let's take our little address here. Let's see, I don't want the new line. Well, it doesn't really matter, but I will switch over to the meteorite API as I've named it. There's actually no API involved, but fun name. Our radius in meters will start something small like 100. This is a nice apartment building I used to live in, so little radius, but lots of damage. 20 houses hit. We're getting about what's that? Yeah, I didn't listen. It was too hard to put the commas in, so I'm just gonna highlight for our commas' sake. We got 14 million in damage, and I thought, well, that's not very much, so let's run it back, and let's get 400 meters this time. This one's going to need to think for a little longer. It's going to hit a lot more houses, but we should come back someday. There we go. 498 houses with a 400 meter. A house is a little bit of a loaded term. A lot of these are apartments it's hitting, but we did get a solid $600 million in damage. So yeah, that's you don't want a meteorite landing in an apartment complex or by several apartment complexes like this one.
Yep.
Yeah, so that one's pretty cool. All right, well we have yet another little brain break, our reminder for the nonsense code word. There it is typed out. That way you know that it's actually nonsense, not actually nonsense.
Make sure to capture that.
Make sure to capture that. All right, well, on to our crown jewel, neighbors. Well, maybe you're like me. Yeah, okay, I can't lie. I'm sorry. I'm not like this. But maybe you're like the stereotypical developer and you don't want to go meet your neighbors. Well, I've got a tool for you. So we're going to it's very similar to the last one. We're going to enter the number or the address of the neighbors you want to know about, or sorry, well, you'll enter the address you want to start with, probably your house. And then we will use Street to validate that. Reverse geo once again to grab Smarty keys, and this time we'll be grabbing from the property data the owner's name. So you'll see that this has some pretty obvious pitfalls, but so it might not necessarily tell you your neighbors' names. You might find out that your neighbors don't own their houses, especially if you live in an apartment complex. But without further ado, we're going to change our reverse geo hacking for this because the last one had some pitfalls I want to get over. Also, I found out that the house I live at had that pitfall, so we had to come up with a new algorithm. This algorithm is basically we're going to yeah, this could definitely be optimized. I'd just like to start with that disclaimer. So we have here a lookup for reverse geo, but instead what we're going to do here is we're going to get a box. I don't know if I ever showed the code for box. Doesn't look like. So I'll just tell you what it does. So the box basically takes all of the geocodes you got from Reverse Geo, and it draws a box around them. So it takes the northernmost, the westernmost, easternmost, and southernmost, draws a box around them, and then it says, okay, if I was to draw this box above me to the left to the diagonal, it's going to hit a box all around. So there'll be 8 more boxes it draws. That's what the next up, next right, next down, right, next down, all that. That's just me grabbing every single box around and throwing that geocode. So I'm just going to calculate a new geocode to send in, and then keep sending that up and down, left and right, to make sure that I don't get stuck like I did in the last algorithm. So this has way different ramifications than the last one. You'll see that parallel.fanout. That's a little Smarty magic library. I believe later there's a session by Adam Charlton, and he'll be talking about more how to parallelize this stuff. So, and his code is all open. So I felt okay just leaving that in and saying magic box. You can learn about that later. But basically, I'm using parallelization to speed up the API request, as that is the slowest part of this whole operation, is just waiting for the internet to, get back to you.
Respond.
Yeah, to respond. So here's the actual code we're going to run through. And as you can see, the names of your neighbors that we'll be pulling up will just be the property data attributes, owner full name, owner full name 2, 3, and 4. We'll just throw them all together. Because I've found that sometimes owner name 1 is populated and owner name 3 is populated, but for some reason 2 and 4 aren't. So then I go through and I filter all the empty ones out using filter, and then I also filter out anything in our entire list that ends up not giving us any results for the property data. So here's our demo. Oh, I don't want that new line once again. This is yet another apartment complex that I used to live at. This one, like I said, you're about to notice that there's some pitfalls with apartment complexes on this, but at least it's shareable. So we'll do 5 neighbors. Yeah, as you can see, the neighbors of me there are LLCs. So didn't really help us in that instance, but at least I could demo it, because if I was throwing down all my neighbors' names, I think they'd all write me and be upset with me. So didn't use real neighbors' names, but which is kind of unfortunate, because the real wowza sauce is when I say like, hey, someone from the chat give me an address and neighbors, and then you're like flabbergasted your neighbors' names show up. That's the reaction I had with everyone I showed this off to. But unfortunately, I feel too skeptical about privacy to do that live. So anyway, those are the neighbors of that apartment complex. But it's pretty crazy to see your neighbors' names pop up when you just type an address in.
That's kind of cool though. I mean, even still seeing the LLCs on here, there's definitely, it feels like there might be some implications for fintech, insurance.
Yes.
Lot of different applications, different verticals could use this.
Yeah, I think that the really cool part is that you can take anything on this enrichment page here, using these strategies we've used today, and return it to a user just by them putting an address in. So, or you can use it for analysis. Like you have all of these, like you got the lender's name, you've got the mortgage amount, you've got the assessed value, you've got tax stuff, you've got census stuff. And any of this can be linked in these APIs, chaining up, US Street to Reverse Geo to enrichment. So
yeah, it seems like there's 350 or more attributes at this point.
Yes, yes, so many. So I could have kept going with these had we still had more creative ideas to implement. But anyway, we'll move on to any questions that anyone may have about anything.
Let me pull up the chats here. And go ahead to feel free to ask a few questions that those of you who have it, either on implementation or
I've got the code pulled up so we can look at it.
And Easton can ask some of those things. So I guess Easton, like kind of as we're getting rolling here, one that I see is like what's like some of the most common mistakes in connecting these various APIs that you see?
I think probably so. I think one of the conveniences of these SDKs is they don't require a lot of arguments to get going. You could see that all I needed to include was the street name to do a US street lookup. I think that one of the common mistakes is that you don't realize there's all these configuration parameters you can also include to get, more from your lookup for what you want. For example, I included enhanced mode. I think most people would benefit greatly from using enhanced mode, but aren't using it. And there's also things like component analysis that you can also include there.
Okay.
Especially if you're paying for component analysis, you probably want to make sure you include it in your lookup so it
Yeah.
actually happens. So like I said, I think that the pitfall is just how usable Smarty is, that you can just out of the box use it, and
Yeah.
sometimes that'll just lead to you not researching and realizing, oh, there's more configurations to this. Like maybe there's a more specified case that I can use here.
So you can build it out for your specific use cases.
Right. And I mean, to be fair, most of the time I only need the street argument. So not to say there's anything wrong with doing that, but I think
Sure.
it's good to be aware of all of the other parameters and configurations that are available to you.
So no, there's more. You brought up, let's see, yeah, you brought up in enhanced mode. What is that? Could you shed a little more light on
Yeah.
that?
So enhanced mode, I gave a webinar about a while back. So I'd pulled up all these examples of differences, but basically our API for US Street runs in three modes: strict, invalid, and enhanced. Strict is basically like, I really want to only get the valid postal mailable stuff. So for a lot of customers, that's the choice. Invalid mode will return everything it can to you without whether or not it's valid, and it'll indicate to you that it is valid or not.
There's the
But
transparency there at least.
yeah, but it'll give you something back no matter what, and it'll at least standardize the address, like, shrink things from, like, spelled out road to RD, spelled out street to ST, spelled out north to N, things like that'll standardize, but even if it can't validate it. Enhanced mode is really just it's really just invalid mode with way more capability. So it will return the same address as invalid mode will. However, it will also include additional data. Like if it's a valid non-postal, it can provide rooftop geocodes for those non-postals as well. It's a little more forgiving in its matching logic. Um,
Okay.
strict mode is a little less like, oh, I had two typos in it, now it's over. But enhanced mode is more forgiving. It's still accurate and
Yeah.
will not just green light anything, but it will make a much more educated guess on, well, I think you meant to type it like this. And
Okay.
enhanced mode is also the only way you're able to enable things like component analysis and get SmartyKey back. So.
Okay. And enhanced mode for our users, is that something that is automatically enabled or how do they
No, so
access
by
that?
default, it is on strict. So you have to go and specify, I want enhanced. But
Okay.
basically, every single plan has enhanced mode. So it's not like an add-on that you need to go pay for, unless there's a select few legacy plans that applies to. But
Okay.
if you're getting US Street today, you have enhanced mode.
You have access.
Yeah.
Okay. You talked about component analysis. How is that different from what we offer in validation?
So component analysis is like I'd say basically the greatest thing to ever happen to address validation. It goes through and tells you exactly what components validated and what ones were changed, where the typos were, where we added something in. A very common thing would be, I forgot in my address when I type it out, I always forget the pre-direction. I forget to put the north in.
Redirections.
Component
Okay.
analysis will come back and say, hey, like not only did we change something, but I will tell you exactly what we did. We added a pre-direction. And
Redirections.
it does that for street. It'll say, oh, there was a typo. It'll say that it added things,
Yeah.
it changed things, it abbreviated things. So it's just a very it's the most, yeah, I guess, transparent way of getting your address data back. It just tells you
Okay.
here's exactly what we changed with it, which is really nice.
Uh, Very cool. So yeah, like that's something that's pretty unique, like being able to see what's wrong and or what was changed and why it was changed. That's not something you often hear about.
Yeah,
Let's see.
should have worked
Yeah,
that in
so
my Max.
we have a question here about kind of that Earth, the element, the first demo.
Yes.
So uh, how do we get that information and um, what other use cases could it be used for, I guess?
Risk data, I mean, obviously that was a pretty fun-filled example.
Yeah,
Just grabbing the data to determine what element was threatening your house the most. But I don't know, maybe you find that information useful as well. But I do see
okay.
that definitely being very useful for insurance, if what the risk is of insuring an area.
Yeah.
Because obviously a lot of math goes into that, and it's a lot of calculated risk. Um, I don't know. Do you have any use cases of risk data?
Well, I have an insurance background, of course, and so some of that, we've got Hurricane, is it Irma right now that's going on down there?
I don't
Something something that's coming up as well. Like, um, yeah, being able to create those. But does Smarty have the risk model itself? I mean, you definitely provide some data there, but how does that work?
Um, I know that we have. What I know we have is everything. Oh no, that's not what I want
Yeah,
to. Is everything in the docs.
everything dogs. Okay, and this
So
is fairly new, right?
yeah, risk is very new.
Okay.
Um, which is why I felt like it should be included. So I don't believe we provide any sort of analysis tools with it as much as we just
Mm,
return the data right now.
it's
Um,
kind of the raw risk data.
just the raw risk data right now.
Okay.
Let me let's scroll. There's a lot. Yeah, it doesn't look like we have anything after that. So I think we're just providing you with the raw data from the FEMA website. Um, yeah.
Very cool. So would it be possible to combine both this data as well as kind of that neighbor data? And
Yes. I
what would
think
happen
the
there?
real beauty of it is that the Smarty key, once you get to Smarty key, you have access to all of enrichment data. So which is why Smarty key is so crucial to just hold on to once you get it. Um, it's good to save it with with your address database because then you give yourself access to everything enrichment has to offer, which we could see what all the data sets are up. I guess I could have used this. I
Yeah,
believe products, and then there's your enrichment data. So
very
all this
cool.
data is, well, there it goes. All that data can be chained together
As
to do anything with, as long as you have a Smarty key, you have access to it.
long as you have the Smarty Key, you've got access. Question on Smarty Key here. You talked about at one point anonymizing data as well as non-anonymizing data in a couple of your demos. Like, what's the benefit of the two options? And why does the Smarty Key do that, or what's behind that?
Well, the Smarty key is random, so that's what makes it capable of anonymizing. There's no way to reverse, like we have no way internally as well of taking a Smarty key and being like, oh, well, you see the ones here and the threes here, so we know it's in Texas or whatever. There's no way to go backwards like that
Yeah,
because it's random. So I mean, I think the advantage is really up to what your customers want. If your customers are, okay with the address being thrown around everywhere, then
yeah,
great. But if they want, that anonymous, the to be anonymous, then
yeah,
SmartyKey is a great solution for that. Because there's no way to sit down and look at it and go, oh yeah, now I know where you live. You
yeah.
really just have to get lucky and hit the same address, and it's like 1 in 220 million. So good luck.
Sure. Yeah, so I mean, it seems like too, like that would be very helpful as far as like being compliant with the
Yeah,
various privacy acts I mean, that's really big right now.
yeah. And I mean,
Sure.
if you wanted to get even more anonymous, you could even create your own ID internally and then just, link that to SmartyKey, and then you'll be complete. There's just no chance they can figure it out now. So
No chance I can figure it out. Awesome. Um, let's see here. I think that about wraps it up for our questions. Thanks, Easton. A
of course.
wonderful, wonderful presentation here. Like I say, I see a lot of what Easton just put forward, and that looks like underwriting pre-fill for finance, for insurance, even real estate, right? Like a lot of real estate
Yeah.
tech could really use this. So it's very cool to see that. Thanks for attending, everybody. I hope you're enjoying the rest of Pinpoint.